going to be learning about the semicircle parent function. So we're going to start off with the equation for a circle with the center at 0, 0. So the center is at the origin, and a radius of 6. So what this means is the radius, which is from the center to the edge, is going to be 6. So I'm just going to draw 4 points in all 4 directions and connect them to form a circle of radius 6. So we're going to start off with the equation for a circle, which is x squared plus y squared equals r squared. So in this particular case, we've said that we want our radius, which is r, to be equal to 6. So I'm just going to plug 6 in for r, and that gives me x squared plus y squared equals 6 squared, which is 36. So this is the equation for a circle. The problem with this equation is, as you can tell just looking at this graph, this is not a function. It does not pass the vertical line test. If you were to draw a vertical line, it would hit it at 2 points, so it's not a function. So what we're going to do is make this a function. So let's solve our equation for y. So we're trying to get y by itself. So first I'm going to subtract x squared from both sides. And that leaves me y squared equals 36 minus x squared. Now I'm going to get rid of the square root, or the square, by taking the square root on both sides as well. Square root and the square cancel out, which just leaves you y. The one thing you do need to remember is when you take the square root, you actually have 2 answers, positive and negative. Square root of 36 minus x squared. So you actually have 2 separate functions here when you solve this. So this circle is not a function. Well, we can split it up into 2 functions. We have y equals positive 36 minus x squared, which is going to be the top half of our circle. And then we have y equals negative square root of 36 minus x squared, which is the bottom half of our circle. So even though our first equation, bottom half of our circle. So even though our first equation was not a function, we can split this equation up into 2 separate equations that are functions. So in our graph right here, this top half, this is f of x equals positive root 36 minus x squared, and the bottom half is f of x equals negative square root of 36 minus x squared. So knowing this, we now have the parent function for semicircles. Our equation is always going to look like this: square root of r squared, so whatever the radius is squared, minus x squared. So like the example we just did, square root of 36 minus x squared. So in this case, because it's positive, this is the top half of our graph. So we have, in this case, negative 6, 0, 0, 6, and 6, 0. So this is this graph right here. So notice that all of your points are on the radius. This is a radius of 6. So we can summarize this using these specific points. We know we're going to have one point that is negative 6, which is your r. So negative r, comma 0. We're going to have a point at 0 and whatever your radius is, so 0, r. And then we're going to have a point at r again, 6, 0. So depending on what your radius is, these are the 3 points we're going to use to plot our circle, semicircle. So let's look at the domain. So our domain is our x's. We're going between the leftmost point and the rightmost point. So in this case, negative 6 to 6. And again, we're just going to use r because it's going to differ depending on your radius. Because there is a point here, it's a closed point, we're going to use brackets for both. Now let's look at our range, y. So our lowest point, the lowest point this graph reaches, is actually both of these points are our lowest, and that's at a y value of 0. And it's going all the way up to 6, which again is our r. So it's going all the way up to r, and that's our range. Now some characteristics of this graph. As you notice, it is symmetric about the y-axis, which means that this is an even function. We know that it is increasing from here to here, so from negative r all the way until 0. And it's decreasing from 0 all the way until r. It's increasing for this part, decreasing for the second part. And this graph actually has a maximum. The maximum is 6, and it's at x is equal to 0. So the y value is 6, x value is 0, and again the 6 really we can replace with a r depending on what your r is. Max of r at x equals 0. So here are our characteristics. This is the parent function we're starting off with. Now let's take this and graph it. So let's take a look at number 7. So the reason why we know that this is a semicircle is because it's in this form where we have square root of r squared minus x squared. So looking at this, if our r squared is 16, this tells us right away that our r is going to be 4. So my parent function for this graph, if this is the center of my circle, my parent function is 4 to the left, 4 up, and then 4 to the right. So this is what the original semicircle would look like. But let's look at what transformations have happened to it. So right now notice that there's a negative on the outside. That negative affects our y, which really means it's a reflection about the x-axis. There's also a +3, which again is on the outside, which tells us we're adding 3 to our y's, which means we're moving up 3. So which one of these do we do first? Our reflection, as usual. So what I'm going to do is take all these points reflected about the x-axis. So really the only thing that changes is this one goes down here. So these are the 3 points now. And now that I've reflected it, all I have to do is move all of them up 3. So I'm going to take this point, go 1, 2, 3. This point goes up 1, 2, 3. And this point goes up 1, 2, 3. And then I'm going to connect them in a semicircle. And this is my function. So let's look at our domain. Our domain is from -4 until 4. Again, both brackets because they're closed points. Our range is, our lowest point is -1. Highest point, both of these points are at our highest point of 3. Okay, let's look at our next problem. So again, we're starting off with, we know that this is in the form r squared minus x squared. What is our r? So what squared gives us 9? We know our r is going to be equal to 3. So again, I'm going to start off with my parent function, which is 3 to the right, 3 up, 3 to the left. So this is what my semicircle would originally look like if it wasn't transformed. Now let's look at what has happened to it. So this 2 on the outside tells me I'm multiplying my y's by 2. So this is a vertical stretch by 2. -5 on the outside means I'm subtracting 5 from my y's, which means I'm moving down 5. Which one do we do first? Our vertical stretch. So what we're going to do is multiply, let's take these 3 points, we want to multiply all of our y's by 2. So this one right here, your y is at 0. So this one actually doesn't move. This one also doesn't move because they're both at a y value of 0. So the only thing that's really being stretched is this point right here. Before it was at 3, now we want to make it 6. So it's stretched to up here. So now, this is what my vertical stretch looks like. All I have to do now is move all my points down 5. So this point goes down 5, 4, 5. This one goes down 5, 1, 2, 3, 4, 5. As well as this one. And notice this one isn't so much of a circle anymore because it's been stretched vertically. It's more of an ellipse or an oval, half of an oval. Let's do domain and range. So our domain goes from -3 until +3. These are the left and rightmost points. Our range is going from our bottom, which is -5, to the top, which is +1. And that is my domain and range. Okay, last two. We're going to now do the opposite, where we're going to start off with the graph and go back to the equation. So with these, the important thing here is to identify the center of your circle. So for number 9, this is the center of the circle, right? So this is what has been shifted. So for this one, before the circle was down here at 0, 0. Now it's gone up 6. So it's been shifted up 6. From here, now we can calculate our radius. So from here all the way to this point, we can count 1, 2, 3, 4, 5, 6, 7, 8. And we know we have a radius of 8. If it's a radius of 8, we can already plug this into our parent function. So because it's r squared minus x squared, r is 8. 8 squared gives us 64. So we know that our parent function is square root of 64 minus x squared. It's gone up 6, which means we're going to be adding 6 to our y's. So it's going to be a plus 6 out here. There's one more thing that's happened to it. Notice it's the bottom half of your circle. So it has been reflected across the x-axis, which means that our y's have changed signs. And so we want to put this negative in front of the square root on the outside, which tells us it's going to be the bottom half of our circle. So this is my function right here. Okay, let's take a look at number 10. So again, you want to start off with the center, which is right here. Clearly no shifts, so it's not moving up or down or left or right. So again, let's find our r. We're going to count out from the center. 1, 2, 3, 4. We have an r of 4. So again, let's first write our parent function, r squared minus x squared. R is 4, so this is going to be 16 minus x squared. And so our parent function is 4 to the left, 4 up, 4 to the right. Look at what has changed. So this is what it would look like if it was just square root of 16 minus x squared. Clearly this has been stretched vertically because it's been pulled up. It's taller now. And if you notice, before it's supposed to be at 4, now it's at 8, so it's vertical stretch by 2. Which means we're multiplying our y's by 2, so we're going to put the 2 outside of our square root. And this is my function for this graph.